children, I am B. Sunkamma, PSCRT, KGBV Guntakal. Let us discuss 9th class physical science subject, second chapter, laws of motion. We observed the changes in motion of many objects around us. We discussed about physical quantities like velocity and acceleration in the chapter motion. We wondered to know that Aristotle, the great philosopher of that time, also concluded that the natural state of an earthly object is to be at rest. He thought that the object at rest requires no explanation of any moving body naturally comes to rest. Galileo's experiment of motion of an object and inclined plane. When a marble rolls down an inclined plane, its velocity increases, and when it goes up the second inclined plane, its velocity decreases. If the inclination of both the planes are equal, then the marble will match the same height which it rolled down. If the inclination of the second plane is decreased, it will travel more distances to match the original height. If the inclination of the second plane is marble horizontal, the marble will travel forever trying to reach the same height. An unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. Sir Isaac Newton. Sir Isaac Newton proposed his three fundamental laws which explains the connection between force and change in motion. There are three laws are popularly known as Newton's laws of motion. Newton's laws of motion. Newton's first law of motion states that an object remains in a state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. Inertia. The natural tendency of object to remain in a state of rest or in uniform motion is called inertia. This is why the first law of motion is also known as the law of inertia. Examples of inertia. If a striker hits a pile of coins and a carom board, the lowest coin moves out, and due to inertia of rest, the other coins fall down. If a coin placed on a playing card over a tumbler is flicked with the finger due to inertia of rest, the coin falls down into the tumbler. When we travel in a car and the driver applies the brakes suddenly, we tend to fall forward due to inertia of motion. When we are standing in a bus and the bus begins to move suddenly, we tend to fall backward because our feet in contact with the floor moves forward, but the upper part of the body continues to remain at rest due to inertia of rest. Inertia and mass. A body at rest continues to be at rest, and a body in motion continues to be in motion. This property of a body is called its inertia. The inertia of a body is measured by the magnitude of force required to change the state of the body. The force required to change the state of a heavier body is more than the force required to change the state of the lighter body. This is because the mass of the heavier body is more than the mass of the lighter body. So the mass of a body is a measure of its inertia. Momentum of a body. The momentum of a body is the product of its mass and velocity. Momentum is equal to mass into velocity. P is equal to m into v, where p is the momentum of a body, m is the mass of the body, v is the velocity of the body. If a body is at rest, its velocity is 0, and so its momentum is also 0. The SI unit of momentum is kilogram meter per second, or kg meter kilogram meter per second. Example, a truck moving at a very low speed can kill a person standing in its path because of the heavy mass of the truck. A bullet of small mass, when fired from a gun, can kill a person because of the large velocity of the bullet. So the impact of a body depends upon its mass and velocity. Next I will going to Newton's second law of motion. Newton's second law of motion states that the rate of change of velocity, the rate of change of momentum of an object is proportional to the applied force in the direction of force. Mathematical formulation of second law of motion. If an object of mass m is moving along a straight line with initial velocity u and is accelerated to velocity v in time t by applying a force F, then initial momentum P1 is equal to mu, final momentum P2 is equal to mv, change in momentum P2 minus P1, that is equal to mv minus mu, that is equal to m into v minus u. Rate of change of momentum m into v minus u by t, or the applied force F is equal to m into v minus u by t, or F is equal to m into v minus u by t. but v minus u by t is equal to a acceleration. So F is equal to kma, where k is a constant of proportionality, or F equal to ma. Force is the product of mass and acceleration. The SI unit of mass is kilogram and acceleration is meter per second square, or ms to the power of minus 2. So the unit of force is kilogram meter s to the power of minus 2, or Newton. Its symbol is N. Next I will go into Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction, and they all act on two different bodies. When an object acts some force on second object is also exert same force in opposite direction. That is Newton's third law of motion. To prove that action and reaction are equal and opposite, take two spring balances A and B connected together. Fix the spring balance B to a rigid support. When a force is applied by pulling the free end of the spring balance A, if the spring balance shows the same readings, this shows that the force exerted by the spring balance A on B is equal but opposite in direction to the force exerted by spring balance B on A. The force exerted by the spring balance A on B is action, and the force exerted by the spring balance B on A is reaction. Examples of action and reaction. When a bullet is fired from a gun, it exerts a forward force action on the bullet, and the bullet exerts an equal and opposite force on the gun, and the gun recoils. Another example, when a sailor jumps out of a boat, he exerts a backward force of the boat, and the boat exerts an equal and opposite force on the sailor, and the sailor jumps forward. When an air-filled in balloon is released, the force of the air coming out of the balloon action, that is, exerts an equal and opposite force on the balloon, that is reaction force, and it moves upward direction. When a rocket is fired, the force of burning gases coming out, that is action force, exerts an equal and opposite force on the rocket, and it moves upward direction. First, I will going to conservation of momentum. The law of conservation of momentum states that the sum of momenta of two objects before collision is equal to the sum of momenta after collision, provided there is no balanced forces acting on them. This means that total momentum of the two objects is unchanged or conserved by collision. If two balls A and B of masses MA and MB are traveling in a straight line with initial velocities UA and UB, and if UA is less than UB, the two balls will collide with each other during collision at a time t. Ball A exerts a force FAB on ball B, and ball B exerts a force FBA on ball A. If VA and VB are the velocities of balls A and B after collision, the momenta of ball A before and after collision are MA, UA and MA, VA, and the momenta of ball B before and after collision are MB, UB and MB, VB. Change in momentum. Change in momentum of ball A during collision, that is equal to MAVA minus MAUA. Rate of change of momentum of ball A FAB, that is equal to MA. Change in momentum of ball B during collision, that is equal to MB VB minus MB UB. Rate of change of momentum of ball B FBA, that is equal to MB. According to Newton's third law of motion, the force FAB exerted by ball A on ball B is equal and opposite to the force FBA exerted by ball B on ball A. Therefore, FAB is equal to minus FBA, that is equal to MA is equal to VA minus UA, that is equal to MA into VA minus UA, that is equal to minus MB into VB minus UB, that is equal to MA VA minus MA UA is equal to minus MB VB plus MB UB, or minus MA UA minus MA UA, that is equal to MA VA minus MB VB, or MA UA plus MB UB is equal to MAVA plus MBVB. Momentum of the two balls before collision is equal to the momentum of the two balls after collision. Thank you.